Welcome everybody. Let's look at another example of using the comparison and limit comparison tests for infinite series. So when we use the limit comparison test or the comparison test, we want to choose a series for which we know the behavior that maybe is closely resembling the series that we're interested in. So one way of finding that is to look at the terms of the series that we're given in the limit to see, well, what maybe does this thing start to look like as n gets very large. And so if we've got our series 5n to the fourth minus n squared over 19 over 6n to the sixth plus n to the fourth minus 2, well, as n goes off to infinity, so when n is very, very large, as n goes off to infinity, these terms n squared minus 19 and the n to the fourth minus 2 start to not matter so much. And so this thing really starts to look like 5n to the fourth divided by 6n to the sixth, or really 5 over 6n squared. And so in the limit, because we have kind of similar behavior there, we're saying, all right, well, so can we use the behavior of this series? So we've got a 5/6 1 over n squared as n goes from 1 to infinity. Can we use the behavior of that series to then predict the behavior of the series that we're interested in? And in this case, we can. And for this one, because it's a convergent p-series, then probably our first series is going to also converge, but let's use the limit comparison test to see that that's actually going to be the case. So for the limit comparison test, we look at the limit of the ratio of our terms. So we're going to look at the limit as n goes off to infinity of our unknown series. So for our unknown series, we had 5n to the fourth minus n squared minus 19 over 6n to the sixth plus n to the fourth minus 2. And we're comparing this to the series that we know about, in particular, 1 over n squared. So if we look at this limit, let's see what happens. So we have the limit as n goes off to infinity, 5n to the fourth minus n squared minus 19 over 6n to the sixth plus n to the fourth minus 2 times our n squared over 1. Well, by the time we distribute, what we end up with is we have a 5n to the sixth minus n to the fourth minus 19n squared divided by 6n to the sixth plus n to the fourth minus 2. So because in this case we have a rational expression with the degree of the numerator equal to the degree of the denominator, then what that tells us is that the limit is really going to be nothing more than the ratio of the leading terms. And so what we really end up with is this really looking like 5 over 6. So then according to our limit comparison test, we're in the first case, where our limit is some non-zero value, then that tells us that the convergence, so the two series have the same behavior. And in particular, since our known series, our 1 over n squared, is a convergent p-series, that our conclusion is that our series, that the given series, converges. So I hope this has kind of been a straightforward example of using the limit comparison test for determining the behavior of an infinite series. Hope you've enjoyed it, and I will see you guys next time.